Hello, my name is Gavin Baker, and this is the final lab of Physics 2. Today, I'll be talking about how magnets break using magnetic fields and Faraday's law, along with many other laws. So, in this lab, we're trying to understand the interactions between flux, magnetic fields, gravitational forces, basically just forces and principles that all oppose each other. Now I'll explain what concepts support our observations in the lab, and later I'll explain the data and the code. So for the procedure, we decided to first measure the dimensions of the foil and the magnet, and we had one person drop the magnet through aluminum foil while someone else recorded the time and the video. We ran 5 drop tests and recorded the time and distance travel. We took the average and we used that average to figure out for the glow script. The magnet moved the quickest at the beginning and the end and decelerated the most due to the magnetic field around the magnet and the foil. And here is one of our classmates dropping the magnet through the foil. And as you see, it slows down because of the magnetic field produced inside of the foil. And here is just us measuring the foil itself. So, connecting the data into physics, we did not use a Ferris tube because that would have induced another magnetic field that would have interfered with the magnet, and there would have been another variable to account for. And without the foil tube, the magnet would simply fall faster because it's just the force of gravity pulling it straight down. So here are the important parts of my glow script code, like initial values, constants, and equations to graph the data. I used the observed data and initial calculations to power the rest of the code, and there is a link in the description for more information. The glow script produced the model and the graph on the right to show the change in velocity over time and magnetic fields as the magnet fell. So, for the discussion questions, the red glow indicates a counterclockwise motion, while the blue glow indicates a clockwise motion due to Lenz's law, where they are opposing each other, because the induced flux is opposite of what is producing that flux. The magnet would still fall slowly down even if the physical magnet and the poles were flipped, because it would still bounce out as it's falling. The computational model seems fairly consistent real life. It's not as easy to perfect a computational model with real life because with real life there are some variables we didn't account for. The graph reveals how the velocity is constant in the middle while going through the foil, but drops down really rapidly, increases in the negative direction whenever it is not in the foil itself because it's just the force of gravity. So, what? What if and why? If the resistivity of the conductor approached 0, then the braking force would equal the gravitational force, because there needs to be some sort of balance. And if there were holes and slots in the tube, that would disrupt the flow, but still allow the magnet to break, just not as effectively, because there are more areas for the energy to be displaced, and it isn't as perfect. Thank you so much for watching, and I hope you have a good rest of your day and rest of your semester.